The next algorithm we're going to take a look at is called the copy over algorithm. So the idea with this is we're going to scan the list from left to right just like we did before. The difference now is that for each legitimate value or each non-zero value, we're going to copy that into a new list that our algorithm is going to create. So we're going to create the second list and we're going to store the legitimate values into this list. So the original list with the zeros will still exist, but now we're going to have this new list that contains only the non-zero values. Here is the same list that we used in the previous algorithm. So notice that we have 3 different zeros. So what we're going to see is we're going to ignore those zeros and we're going to copy the remaining values into a new list. So we start by taking a look at the first value. That's a 0. So since it's 0, we're going to ignore it and we're going to move on to the next item in the list. We look at the next item in the list and we see that's a 24, so it's not 0, so we're going to add it to a second list. So the way I demonstrate it here is I just create a second list below the original list and we'll just keep adding values as we go. So we see that we add 24 to this list. The next item in the list is 16. Once again, that's also non-zero, so we're going to add it to our second list. We then look at the fourth item. That is a 0, so we're going to ignore it and take a look at the next item. We see that is a 36. It's not 0, so we're going to add it to the second list. The next value is 42. It's also non-zero, so we're going to add it to our second list. 23 is the next item. It's also not 0, so we'll add it to our list. 21 is the next value. It's also not 0. We get a lot of non-zero values. That's okay. So we're going to copy it and put it into our second list. We then read a 0, so we don't want to include that in our list, so we're not going to copy anything. We're just going to move on to the next value. We then get to the last value, which is 27. It's also not 0, so we're going to add it to our second list. Since we're at the end, we can say that we're done, and the second list that we produce is now an entire list of non-zero values. Here is the complete algorithm. So the first step is we need to get the value of n, how many items we have in the list, and we also need those n values from the list. So we need to know what is in the actual list. The next step is we're going to have left, which is the place where we're currently looking at in our original list. We're going to set that to 1. And then we're going to set the value of new position to 1. So new position is going to be where we're currently looking at in the new list. So then step 4 is that we're going to repeat some steps as long as left is less than or equal to n. So we're going to repeat steps 5 through 8 as long as we're not at the end of the list yet. So we start at the very beginning. We're going to keep going through the original list and we'll keep going until we get to the very end, which would be at position n. So in step 5, if the item at position left is not 0, then we're going to do steps 6 and 7, which is basically to copy things over. So specifically in step 6, we would copy whatever is in left, that value, and we're going to copy it into position, new position in the new list. Because remember, any value that is not 0, we're going to copy it and store it into this new list such that when we're done, we don't have any zeros in that list. So that's what we're doing at step 6. We're actually copying that value into the new list. And then step 7 would be to increase the value of new position by 1. So once we've copied something over at new position, we need to make sure that the next thing that gets copied is at the next spot in the list. We don't overwrite what was currently there. So we have to increment new position by 1. Now, step 8 just says that regardless of whether or not we actually copy something into our new list, we need to increment left by 1. We need to look at the next value in the list. So if it's 0, well, we don't do step 6 and 7. We just move over to the next spot. If it is something other than 0, then we're going to copy that into our new list. And then finally, once we get all the way to the end of the list, we're going to stop our algorithm. Let's analyze this algorithm. And once again, we need to ask ourselves, what is the worst case scenario? So I'm going to ask you that. Pause the video for a second, think a little bit about it, and then resume once you think you know the answer. The worst case scenario for this is that each item has to be copied into the new list. Now, there are n items, and each copying is it's a very simple operation. It doesn't take much work. So this takes theta of n time to copy all the items from one list to another. Now, what about the space? Well, we need another list at most n items. So that means we need theta of n space, because remember, we're looking at how much additional space we need on top of the size of the input. So we need an entire second list. What we find here is that the algorithm is a lot faster than our shuffle left algorithm, because before it was theta of n squared, here this is theta of n. But this algorithm requires more space to make that work. This is actually known what we call the time-space trade-off. So if we want to make an algorithm faster, we're going to need more space. And if we want an algorithm to be more space efficient, it's going to take a bit more time. But usually we just use more space in order to get a faster algorithm.